All right, let's go. So welcome to the CSE116 summer session. So you all saw my email. My name's Jesse. I'm Dr. Hartloff. If you want to call me that, that's fine. But I like to just go by Jesse. We can keep it casual. And with that, let's get right into the course. So the first thing you need to know, a lot of this you saw in the email, but just to make sure we're all on the same page, is the course website, CSE116.com. This is where you can find everything you need to know about the course. Yeah, I gotta get used to this keyboard again. There we go. This is where you can find everything you need to know about the course. And let's just go through it and get this thing going. So the first thing you'll see are all the links for the course. Any external links that we need are right here. The very first one, obviously if you're hearing me right now, you already found this one, is watching lecture. And I want to clear up some of the logistics about this. We just had a question on Piazza too, so let's clear this up. There's a lecture and a lab on your schedule. But it really doesn't work the way they want to schedule it. They want to schedule a lecture and lab, but they give me as much time, actually less time than just lecture in a regular fall or spring semester. So we do need all of that time just to do the lectures. So there's no actual lab like you'd be used to in a fall or spring semester. We use that entire time for lecture. And on the schedule, it's 11 to 1:40 with a 10-minute break in between the two. Instead, I usually give this up for a vote, but it's overwhelmingly in favor of no break every semester, so I just do it the same way now, is go from 11 o'clock to 1:30 with no break and just plow right through. It's live streamed on YouTube. If you need to take a break, just pause the video or rewatch it after. Like you can get up as you wish. You do not have to watch live. You can watch the VODs. There are students in all different time zones. So I like to accommodate everybody in different time zones. So there's no lecture questions. Again, if you're familiar with the fall and spring, there's no lecture questions, no required attendance or anything for the live streams. You can just watch the VODs after on your own time. But with the live streams, watching the live stream, the mess got deleted. All right, I was just going to use you as an example. Is with the live streams, the biggest advantage is that you can interact with me. If you don't really understand an example that I'm doing, or I just didn't explain something very well, you want me to give it another shot, so you can really understand what's going on. You can just say, go in chat. I'm always watching chat right here. If you see my eyes go over here, I'm looking at chat. Post in chat. I'll answer your question right away, unless I'm in the middle of a sentence and stuff. There's a few second delay and all that, all that goodness of being live on YouTube. But the interaction is what you get by watching live. You can't interact with the VOD, obviously. So how would the midterm and final work without the lab time? So with the midterm and final, it'll be 11 to 1:30. Just the entire lecture time that day will be effectively a lab for the midterm and final exam. Those are the one times where you will have to be live. So everybody in different time zones, there's at least one day this semester where you'll have to be live. I won't be streaming on YouTube those days. I'll send an email with all the relevant links for the midterm and or final, and then you'll do the final exam and midterm, kind of on your own, and then submit by the end of the time, by 1:30. So yeah, the one big thing with live is, like Krithik just did, asking questions in chat. I'm always happy to answer questions in chat. If y'all don't use the chat, it kind of defeats the purpose of even streaming live. I could just record everything. Yeah, no problem, Krithik. So our lectures and labs will all be on YouTube, not Zoom. Correct. So lecture and lab, you come to this channel Tuesday, Thursday, 11 a.m. Eastern. You'll be able to watch the live lectures. If you miss a live lecture for whatever reason, come to this channel, watch all the past ones. I also have all the past lectures from previous summers. So if you want to rewatch, if you want to watch those and get ahead on the material, it's mostly the same. It's the same concepts, but the order has been shifted around a little bit. There's small changes here and there, but it's mostly the same stuff. The office hours will be on Zoom though. So to come to office hours, obviously I can't just live stream office hours. That doesn't make sense for that. Uh, doesn't make sense for the medium. For office hours, it'll be on Zoom. Uh, Thought I had something else, but if I remember. Next is AutoLab. If you've taken a, I should have made sure I was signed in on this computer. I have a different computer for streaming, so if you ever see me fumbling around with stuff like this, it's because uh, I'm switching devices a lot. But this is where we submit your assignments. Again, spring and summer, or spring and fall, you're used to this. If not, if this is your first course at UB or your first course with me or whatever, you haven't seen this before, this is AutoLab. This is where you'll submit your programming assignments, all your take-home assignments. There are only 5 of them this semester, but they are fairly involved. I mean, you'll see as you get into them. For each of these assignments, the handout is on the course website. Below the syllabus, I'll skip over that for now, and you can see the handouts for every one of these problem sets. They're all released right now. So right now, today, you could do all of these problem sets if you'd like. If you want to really just plow through the summer and get ahead of everything, you can do them all. This is where you'll submit your zip file, submit it, and then it'll auto-grade it, give you your feedback. You'll get something like this. It'll give you your score and a bunch of feedback about your individual methods and tests and just a good amount of information about your submission. You are allowed unlimited submissions as many times as you want to submit before the deadline. Before the late days, we'll get to it in the syllabus, but as long as the assignment's open, you can still submit. What else might be added, but for people redoing the course, can we start the homework and submit when we are done to be on top of things? Yeah. Oh, yeah, absolutely. Yeah, so you can get ahead of everything. And I always get this question a lot, so let me answer it right now, is if you're retaking the course, and there it is, right there, actually. If you're retaking the course and you've already done these problem sets or similar problem sets, I do allow you to resubmit code that you've already written. It is important that you understand that code and can be able to explain what it is. You are allowed to submit your work if you wrote that code in a previous semester and you still understand how it works. Yeah, if it's your code, it's fine. Yeah, it's not plagiarism if it's your code. Technically, the university policy is that you can't do that. But I allow it mostly because I don't have a great way of policing it. I could pull up your old submissions and, I don't know, if you still understand how that code works, that's why I make that as the line. I don't see the value in making you physically retype it. It's kind of silly. And even if it comes out, even if you do retype it, it might come out looking almost identical to the code that you submitted in a previous semester. I don't know. Enforcing that seems like a pain. If I want to enforce that, I'll just call you in for a meeting and say, explain your code. And if you can't explain your code, then I don't care when you wrote it or if you wrote it or whatever. It's just going to be, we're going to have issues then. In email, I mentioned there were 6 problem sets, but there on the course website, there are 5. Did I mention 6? Sorry about that. It's 5 total, 0 through 4. I confuse myself with the 0 indexing sometimes. You'd think I'd be used to that by now. For me, I'm just redoing it, same. Yeah, if the questions are the same, you can submit the same thing. Make sure you review it, make sure you study it, understand all of your code, because if I do call you in for a meeting, you will have to be able to explain it. But as long as you can do that, then what's the point in making you retype it? All right, next is our office hours. I'll get to that. It's on the Piazza post right here. If you click on this and log in, you can find the schedule. I'll jump there in a second. This one will be very brief though. All of the examples that I give in lecture, all the examples that are in the slides, you can find in this repository. So for example, today we go to topic 1, hello world.java. This will be the very first program that we go through. It's just hello world, but in Java. So if you want to follow along with any of the coding examples, following with this repo, you can take this code, put it into IntelliJ, and play around with the code. I recommend playing around with the examples, modifying them, predicting what the modifications will do, running it, make sure your prediction is right, so you really understand how each code example works and how each feature in the language works. At least by Tuesday, or Thursday, sorry, today's Tuesday. By Thursday, I'll give a demo on how to clone repos in IntelliJ to make sure that we know how to do that. And then when I do that, once I show you how to do that, you can go to this examples repo and grab this link and be able to copy all of this code into your IntelliJ. We haven't really talked about what IntelliJ is yet, so we'll table that for the moment. This I want to collapse. And so the next thing is Piazza. You can go here to ask questions. If you haven't had this in a course before, this is a Q&A forum where you can ask questions. You can ask them publicly if it's relevant to everybody in the class, but most commonly students will post privately. When you create a post, if you post to individuals and then go to all instructors, then you can post questions about your code submissions and any private information that you need. If there's no private information, you can post to the entire class. At least once a semester, somebody posts their problem set code to the entire class. Don't be that person. That's obviously an issue. So make sure you're avoiding that. But when you go right to Piazza, it will link to the office hour schedule. So for example, I'll have office hours right after lecture today. As soon as I turn off the stream, I'm going to hop over to Zoom, open up the Zoom meeting, and I'll be there for an hour and a half right after lecture. I might have office hours on Thursday too. We'll see how much traffic office hours gets, how much demand there is. We also have a TA, Miriam, who will have office hours. She hasn't, I think she's out of town at the moment. When she gets back, she'll get her office hours on the schedule as well. Not positive when those will be yet, but they'll be added. So if the questions are the same, yeah, I already answered that. Will there be time to learn how to make test cases? Yes. At lecture 7, so Tuesday, June 16th, that's what I'm going to be talking about the whole lecture. It's talking about how to make test cases. This is one of the changes we made in the course recently, last semester, is we moved testing quite a bit later than it used to be. It used to be week 3. So it is still there, but the problem sets that come before it, so problem sets 0, 1, and 2 don't require you to make test cases, but once we get to the testing lecture, the next 2, 3, and 4, problem sets 3 and 4 will have you writing test cases. Before that, I always recommend writing test cases based on the ones that we give you, and then using those as a template to create more, but not until that lecture are they going to be required. And good a time as any to mention, if the audio levels, some summers, like I'll lecture for half a lecture and then somebody will be like, oh yeah, the audio was really crappy quality, or the audio was way too loud or whatever. If the audio is ever messed up, I do appreciate if you let me know in chat right away, if I can try to fumble it around and fix it. If it's just too loud or too quiet, I can just adjust the slider over here and fix that. But if the quality's crappy, then that's something I got to work a little harder on. But always let me know if the audio's way off, up or down. Okay, next is UB Power, which actually we rebranded back to just the tracing tool. This is where we're going to do our memory diagrams, which if you don't know what that is yet, don't worry, we will get into it, deep into memory diagrams. And this is going to be nice streaming because I can fit so much. Oh, that's way too small though. I can fit so much stuff on the screen. Usually I have to put this on the projector, so I just can't fit that much information on. I probably do have to zoom in quite a bit here. I don't know why that's looking so blurry. But this is where we'll do all our memory diagrams. I'll have two of these in today's lecture, so we're going to see this right away, right from jump today. And then what's up? I am Stray. I am Stray. What's up? Uh, and this is where you'll do your midterm and final exams. The midterm and final will be traces. I'll get to that in the syllabus and explain the details. But this is the tool that you'll use to do the traces. So I'll do them in lecture using this tool. You'll do them on the midterm and final using the same exact tool. So you'll be used to the layout. You'll see all the exact buttons that I click when I do my traces. You'll do the same exact thing when you're doing the midterm and final. So when I'm doing these in lecture, make sure you're paying attention, hopefully following along. I have trouble getting students to do practice, just traces for practice. Someday we'll require them, but for now it's up to you to do practice traces on your own. And then memory diagram reference. So in that tool, there's just a lot of the basic usage of that tool. This will go through a lot of how to do traces for a lot of the topics that we'll cover in the course. So using this as a reference can definitely help if you don't want to rewatch lectures or whatever, whatever your preference is, or do both. That reference is there for you. And then finally, the Discord. Let me catch up on chat though. What are the limits and resources we can use to get help when we need, other than AI like Geek for Geek? You can use whatever resources you want as long as they are helping you learn in the course. So my criteria is that you have to be able to explain the code that you submit and explain your thought process of how you came up with that code. So if you go to Geek for Geeks and you find like basically the solution to the problem that I'm asking, you code that up in your submission, but you don't really understand how it works. You're just like, I don't know, the internet told me to do that. That's going to be an F in the course. That's an AI violation. That's no good. Obviously, you can't use LLMs, cloud, ChatGPT, etc. You have to be able to understand what the code does that you submitted for credit. And the way I check that is I'll call you in for a meeting. I'll say we have to meet, send you an email. We'll meet obviously on Zoom since it's a remote course. And I'll say, tell me how your code works. Prove to me that you actually wrote this code. And a surprising number of students will say, oh, I just got that from the internet. And then I say, you failed the course. Which are always unfortunate conversations. I'll give more details when I get to the AI policy. But that's basically what it is. Will there be tracing practice like we had in the spring semester? I won't have explicit. Actually, I could just use the same practice traces we had last spring. But I don't intend to have explicit practice traces. But you can go to any of the code in the repos or any code that you've written, any code on your problem sets, and just trace any code. I always tell students, like, you have unlimited practice traces. What you don't have are the solutions, but if you use the debugger in IntelliJ, it'll give you all the same information that's in the solution of a trace. So you can have infinite practice there. Or you can do trace through some code, then come to office hours with your trace, share your screen, and say, hey, I traced this code. Can you look it over and tell me where I might have went wrong or if I did good or anything? Miriam and I will be always happy to go through a trace and help you practice with traces that way. Very few students ever take us up on that offer, but I'm always happy to do that. Will the midterm and final be on lockdown browsers or no? Or how does the assessment work for the summer courses? It's kind of on the honor system, if I'm being honest. I'm personally against lockdown browsers. I think it's spyware. But also the CSE department, we have a policy, we voted on it and everything, and banned lockdown browsers in any CSE course. If any CSE course at UB tells you to use a lockdown browser, let somebody know. Let me know if you don't know who else to come to. Let the directors of undergrad studies know. Let somebody know. Because I as a department have a stance that we're against it, and I'm personally against it as well. That we should never ask students to install that on their systems. Now that does create the loophole, like, well, we can't really restrict what you do during those. So, uh, yeah, you're not supposed to use any outside resources for the midterm and final exam. Can I enforce that without a lockdown browser? Well, I'm not going to go to a lockdown browser, so. Uh, but the traces, it would follow the same as your written code for your problem sets. Is if I call you in for a meeting and say explain your trace and you can't explain it, obviously we're going to have problems at that point. So that's my method of enforcement. Can you go into more detail on how the tracing quizzes will work on the midterm and final? Yeah, I'll go through the whole syllabus. It'll be in there. Um, I'll give you all the details about it. The short of it is the midterm, and you know what? I just gotta get to on the syllabus. I don't think there's a short way to say it. Um, Maybe there's. There's two categories: OOP and data structures for traces, and the midterm and final will each have two of each of those. So you get four OOP traces, two on the midterm, two on the final, two data structures traces, two on the midterm, two on the final, and you have to get at least one of each correct. So once you get one OOP trace and one data structures trace, then you're good to go for traces. Will there be any coding quizzes or interviews? No. For the summer course, we do have to trim quite a bit out. So if you're retaking the course from a fall or spring semester, you're going to notice a lot of things missing from the summer. It's mostly because a 6-week course and effectively no lab sections and only one TA. There's just only so much I can pull off logistically. And interviews and coding quizzes got to go. Coding quizzes, because since it's all remote, like a coding quiz is basically a take-home programming assignment. So what's the point? Interviews just logistically doesn't really work. The traces is the one thing that we can keep from lab. Do we have to do the final if we pass the midterm? No. So the last link on here is a Discord. I've been using this same Discord since pre-COVID. So there's a ton of students there. If you just want to go to the Discord and chat with students from all kinds of grade levels, if you want to ask them about 220, 250, or the job market or whatever, all kinds of students there. Or go into the 116 channel and ask 116 specific questions. I like to just offer that as a place for students to chat. In the fall and spring semesters, I'll use that during lecture. I'll be watching it on my phone, but we have YouTube chat, so there's no need for me to use it in lecture at all. But I'll still leave the link on here so you can go chat with people. Okay. Where's my clock? There it is. Okay. So let's get into the course proper. That's all the external links. Let's get into the course. And these do collapse. You saw me do it briefly before. If you click any on the top bar of any of these sections, it'll collapse. So once you read the syllabus, you're fully familiar with everything in the syllabus. Feel free to collapse it so the content is just further up on the screen, even the links if you're done with those. And then as we go through each lecture, you'll see me start collapsing these too. So once we get to the fourth lecture next Thursday, mine's going to look probably like this. I'll probably have them collapsed. So if you see that, just know that's what's up. I'll always have students like 3/4 of the way through the semester shocked the first time they see that. Like, I didn't know those collapse. I've been scrolling through the whole syllabus multiple times a day. They do collapse. So the course is all about kind of 3 categories. I would almost add testing. Testing used to be one of these two. But 3 categories: object-oriented programming, data structures and algorithms. With OOP, we're going to learn about classes, creating objects of those classes, inheritance, and polymorphism. With data structures and algorithms, we're going to learn 3 new data structures: linked lists, trees, and graphs, and various algorithms to work with them. And then memory, as we go through the entire course, we're going to do traces of all kinds of programs, and you'll do the memory traces on the midterm and final exam. So those are kind of our 3 foci in the course. And with a focus on what happens when our programs get large, how do we organize our code? That's where OOP helps. And how do we have efficient run times? That's where our data structures and algorithms help. And just understanding how everything works is critically important. Just as you go through, we do traces throughout the semester, and you after 116 you might not do another trace. It's not something you'll do in industry. Nobody traces code in industry, but it's important to be able to trace code. Anyone in industry, you give them a tracing problem. Hey, can you trace through that code that you wrote? They'll be able to do it. And that's what we want to get in 116. Show me that you do understand how this code runs, and then you'll never have to write another trace again. But you better be able to understand and explain how your code runs at the level of a memory trace, which is what happens in stack and heap memory as your program executes. So what's everything that happens in memory as your program goes through? How does the computer run your code? That's really what we're getting at with the memory stuff. This is the first of many. I might actually not dwell on this so much as I usually do, but do not fall behind in the course. You saw it multiple times in my intro email. Do not fall behind in this course. Every lecture is a week of content in a fall or spring semester. So if you miss one lecture, you fall behind by one lecture, you're like, I'll watch the VOD, and then you kind of neglect it and don't watch the VOD for a few days. You're a full week behind in a regular semester. It's easy to fall behind if you're like, well, he says there's no attendance, I'll just watch it later, and then later comes a little too late. You're really risking failing the course. That's how students fail, especially in the summer. It's true every semester, but especially in the summer. You miss one lecture, you take one day, you're like, I'll do it tomorrow, I'll do my problem set tomorrow. You're risking failing the course pretty much immediately. Things go way too fast, and right now we can see, where are my stats here? Oh, there it is. Somewhere between 24 and 26, depending on what number I look at. Watching right now, half of the class is already skipping the first lecture. Maybe they're going to watch the VOD, maybe, but a lot of students, and I've even had myself, I've done this as a student. Whenever lectures are recorded, I'm like, I'm not going to go to lecture today, I'll just watch the recording. I'll watch it later today, and then I just don't, and then I'll watch it tomorrow, and then I just don't, and then all of a sudden I'm behind, and then I stack up a few lectures, I get way behind. It's an easy trap to fall into. Half the class is already falling into that trap right now as we speak. Like, that's wild. That's wild to me. But it's easy to, not wild to me, I just admitted I did the same thing. But I would get caught up. I never let it bite me. And for what it's worth, I never did that in a technical class. I did it in gen eds. But don't fall behind in this course. The expectation is 12 hours per lecture. It's usually 12 hours per week in the regular semesters, but a lecture is a week of content now. So that's watching lecture and then 9.5, I guess, hours outside of lecture working on your problem sets and preparing for the midterm, doing traces, preparing for your midterm and final exams, doing practice traces. That should be 9 hours per lecture. So this is 18, well, kind of 9.5, but whatever. So 18 hours per week. Aside from watching lectures, you should be working on your problem sets. That's the expectation. That it can take a while to learn those, to do those problem sets. Admittedly, this might be a little less since we don't have the game features assignments. Usually these are the numbers with game features. But for some of you, it might be still 18 hours a week outside of lecture, 9 hours per lecture. So don't be surprised if the numbers get pretty high to complete those problem sets. If you're going for max score, of course, as well. It's going to take a lot. So if you skip a lecture and now you're trying to do 18 hours in a single day potentially, you can crunch your own numbers and figure out how easy it is to get behind on this. And this does assume that you know all of the 115 concepts. There's a lot of students who get into 116 who squeak by 115 with like a C and kind of barely understood the concepts and just barely got through all the assignments in that course. And then they come into 116 with a very weak foundation understanding of computer science and programming. For them, this number is going to be way higher because you have to do everything you missed from 115 and also everything in 116 all in a 6-week time period. I think you get the point. Just don't fall behind in the summer. Stay up to date. If you're in a time zone where it's currently, as I'm streaming, 2 a.m. or whatever, you're not going to make the live lectures. Make sure you watch the lectures the same day. If you're putting it off at all, you're really risking falling behind. You put it off 2 days, and from a Tuesday, now it's already Thursday, now you're 2 lectures behind, and you're basically cooked at that point. It's very hard to come back from that. Unless you already know all the content, but if you're someone who got a C in 115 and struggled in 115, you know what you got to do. Stay up to date on everything. And I'll try to not harp on that too much, but I want to give at least one strong warning for that. For the coding assignments, are there some problems we can't do if we skip over and risk those points? No. So in other semesters where we have the game features, they do build on each other a bit. With the 5 problem sets this semester, they don't build on each other at all. So if you do miss one, it's going to be much, much harder to pass, of course. Well, we'll get it, not of course yet, because I haven't explained the points. It's going to be much harder to pass the course, but you will still be able to pick up on the next problem set. I would argue that you probably won't be able to. The problem sets don't build on each other, so technically you can. But if you can't do problem set 1, you're not going to be able to do problem set 2. Like conceptually, each one does get a little more complicated, a little different, but a little more complicated. So if you can't handle problem set 1, you're not going to be able to handle problem set 2 if you're just like, I'll skip that one. It's not a good idea. Not a good idea. Okay, but technically possible. Oh, like a part of it. Yeah, if you can't do like the last question of a problem set, the last question's usually pretty tough. So yeah, I see what you mean. Sorry about that. If you can't do like the last question of a problem set, yeah, you'll be fine. The last question of each problem set is, for the most part, meant to be the earn your A question. So if you can't do that last one, well, maybe you just walk away with a B and don't do the last question on each problem set. That's perfectly fine. You're going to be able to do the next problem set, at least the first 40 points of the next problem set, just fine. Okay, so there's 2 learning objectives. There's usually 10 in the fall and spring. I kept the checklist format for this, but it does look a little silly, only being 2 things to check off. But here's the learning objectives. I explained this briefly in response to a question, but let's make sure everybody gets this, because it is a little confusing. I tried to word it the best I can, but it's a little confusing still. So let's explain it and make sure everybody's on the same page with this. There are 2 learning objectives of the course that you have to complete to pass the class. So your grade is going to depend on your problem sets that we'll talk about in a bit, but that only matters if you complete the 2 learning objectives, which are a tracing for OOP and tracing for data structures, going through a trace on the tracing tool for each of these categories. So on the midterm, you're going to be given 2 traces. You'll get 2 traces for OOP, 4 traces total. 2 traces for OOP and 2 traces for data structures. The learning objective is to complete a trace for that category. So you have 2 chances for each of these on the midterm exam. On the midterm, you take the midterm, and say you pass one of and all the traces are graded pass-fail. Miriam and I will manually grade them on a pass-fail basis. If you pass one of the OOP traces, then you have completed the tracing OOP learning objective. If you pass one of the data structures traces, then you've completed the tracing data structures learning objective. And that's all you need to do, is pass 1 trace of each type to complete these learning objectives, and then your grade will depend on your problem sets. If you don't complete either of these traces, at least 1 trace of each type, then you will fail the course. You have to do this. It's not optional. It's not, well, I'll just take a hit to my grade. This is you have to do this to pass the class. So everybody has to, because it's important for everybody to be able to trace through these programs. It's one thing to write code, but you also have to be able to read code. And this is my way of getting your reading code and your writing code both assessed in the course. So on the midterm exam, you have the two traces. If you say pass one of the OP traces but fail the other one, you pass one of the data structures traces but you fail the other one, you've completed both learning objectives. In a lot of courses, that would be a 50% on the exam. In this course, it's you've completed both learning objectives and you are done with learning objectives. If you pass all four of the traces, doesn't really affect your grade. There's no extra improvement for your grade. There's no extra that you can earn by completing all four traces. You just have the satisfaction of knowing that you did great on all four traces, which is really good. You should all strive for that. But it doesn't affect your grade. Passing either one or both of them has the same effect on your grade. But just to make sure this is very clear, there are four total traces. If you pass both of the OP traces and neither of the data structures traces, that means you've completed the tracing OP learning objective, but you have not completed the tracing data structures learning objective. So you still are at risk of failing the course in that situation. If you don't pass at least one trace of each category on the midterm, then you have the final exam. The final exam is going to be the exact same structure, two traces of each type, and it's still the same thing. You have to complete at least one trace of each type. So a few different scenarios. In the situation I just explained, you passed one or both of the OP traces, but you didn't get either of the data structures traces on the midterm. You go into the final. Going into the final, you've already completed your OP learning objective, so you don't have to do the two OP traces. You don't even have to look at them. You don't even have to open them. But you do have to pass at least one of those data structures traces on the final exam in order to pass the class. So effectively, for each learning objective, you have four chances, two on the midterm and two on the final exam. And of those four traces for that category, you have to pass at least one of them. So you have to pass at least one OP trace and at least one data structures trace out of the four total that are available across the two exams. So hopefully that makes sense. If there are questions, let me know. So we have the makeup option if we fail the first time on the quizzes. Yep. And if you pass both learning objectives on the midterm, you don't have to take the final. The final's only there as a makeup opportunity because it's so strict. You have to complete both of these learning objectives to pass the course, or else you just flat out fail no matter what else you did. That's pretty strict on the surface, at least. So I want to give you at least two chances for these. Technically four chances. You have four traces for each learning objective and spread across two separate days that are separated by a week and a half. 9 days. Separated by 9 days for the two exams, so you don't get the midterm, you get your scores back, you have time to study and prepare, know what you have to prepare for, come to office hours, get some tracing help and everything, and then go and take the final exam for your second chance. So you have chances for this, and for recommendations, what I see a lot of students do, and it absolutely drives me insane, because I want to see students pass, and this is one of the biggest things students do to set themselves up for failure. They'll show up to the midterm having never done a trace in their lives. They'll watch my traces in lecture, but they'll never practice a trace at all. Like they'll just never do it. So the very first trace that they actually do on their own is on the midterm or in the fall and spring semesters, whatever the first lab is where we have tracing. That'll be the first trace they ever do in their lives, is one that really counts. And I think students do this because they're like, well, if I don't get them, then I have the final exam there. I have some backup plans. Don't do that. You don't want to take the final exam. None of you want to take the final exam. Get it done on the midterm, prepare properly for the midterm, and then you don't even have to worry about the final exam. Final exam day, you can do whatever the hell you want because you're already done with the course. Practice, come to office hours with your practice traces. Miriam and I will be happy to look over them and everything, and skip that final exam. That's what I want to see every single one of you doing. Hopefully, I can just cancel the final exam because nobody needs it. That would be an ideal situation. But I have the track record of students preparing for their first trace is abysmally low. The pass rates on those are absolutely atrocious. And then students will study for the final, and then the pass rates go up way higher on the subsequent attempts. But the first attempt is always just abysmal. And when I ask students, hey, did you prepare for that? Nah, I just watched lecture and like, come on, man, that's not. Like I mentioned earlier, eventually I think we have to add like tracing homework, but that's not the reality for this semester, so I won't dwell on it. But eventually I think we have to have tracing homework to force that. I don't know. But prepare for that midterm, and you'll be fine. Then you don't have to worry about the final. The final will be, because the final is a high stress day. If you need the final, that's a high stress day. So if you can avoid that, it'll help your mental well-being as well as knowing that you passed the class. Okay, so if you complete both learning objectives, then your actual grade depends on the problem sets. 5 problem sets, 50 points each. This doesn't really have to be a chart, but there's, in the fall and spring, there's a whole bunch of items on this chart. I kept the formatting and templating and just said, you know what, it's kind of funny as a chart. I'm going to leave it as that. So every problem set is 50 points. They're all equally weighted, 250 points total. And every problem set has a deadline. On the course website. So for example, problem set 0 is due next Thursday. The deadlines are quick. Of course, it's the summer. So each problem set is kind of released. They're all released right now, but they're kind of released on a Thursday, and then they're due the following Thursday is roughly how it works. And by released, what I mean is by the time by the end of the lecture where the problem set is listed on the course website, at that point you have everything, you're guaranteed to have everything you need to be able to complete that problem set. So in 2 days from now, you'll have everything you need to be able to complete problem set 0, and then you have 1 week after that to be able to work on it and I'm highlighting the wrong thing, and submit it before that deadline. If you can't complete it by that deadline, there is a late policy for this course. You can still submit assignments late, your problem sets late, at a penalty of 20% per day late. So if you're 2 days late, whatever score you get, take 40% off of that, and then that's your score for that problem set. So if you do miss that deadline, you're working at midnight and you just can't quite get it together right at the deadline, you can still submit, keep working on it for another day for a 20% penalty, another day for 40, then 60. And if you're submitting at an 80-point penalty, 80%, not 80 point, but 80% penalty, you might want to cut your losses at that point. Still do it for practice at least, but the point value, you're playing for 10 points at that time. Anything you can do to avoid that situation would be better for you. Is there any tracing questions with answers to practice? I think I will. Somebody else brought this up too already. That I think I do have to, especially with my with what I was just saying, how students will go into the midterm not having done a trace. I think what will eventually be those homeworks. I think I just gotta develop that and release those. Just so you have some more structured way to practice. I'm going to add that to my to-do list, in fact. Trace practice. And then give you some explicit ways to practice these things. I think I got to do that. I think I owe it to you to make that easier to prepare for that midterm. Okay. Late policy points, and then as long as you complete both learning objectives on the midterm and or final, as long as you complete those, if you don't complete those, it's an F in the course. Hopefully I made that abundantly clear. I repeated that many, many times. That you do need to complete those. Doesn't matter if you have 250 points on problem sets. If you only completed one of the learning objectives and say data structures, you failed all 4 traces for data structures. That's an F in the course no matter what else you did, no matter what else happened. The midterm and finals are online. Students take this course from all different time zones. Some of them take the course from their home countries. I'm not going to force you to come in person. They're all online. It's fully remote course. Fully remote. And then if you do complete both learning objectives, then I won't read the whole chart, but this is where your grade is determined. The big thing is hitting this 150 for a passing grade. So if you are skipping points on problem assignments or goodness, you know, if you're bold enough to skip an entire problem set, there's only 100 points that you can miss and still pass the class. So the problem sets, which by the way, the problem sets used to be learning objectives, and you just had to complete every single part of every single problem set, or you failed the course. It got a little, maybe a little too lenient even here, but you can only miss 100 points before you're failing just on points as well. So if you get if you get off to a very slow start and you're missing that problem set 0 deadline, you get a 0 on problem set 0. It's very, very hard to recover from that. You got to be nearly perfect for the rest of the semester, and if you completely miss problem set 0, if you're capable of getting yourself in a situation like that where you're missing problem set 0 entirely, it's probably going to be hard for you to get the rest of the 4 problem sets with only missing 50 points. Make sure you're getting problem set 0. It is the easiest problem set, of course. It's problem set 0 is 115 concepts, but in Java, it's basically the intro to Java problem set. It's not really 116 concepts. Yeah, it's just getting practice with Java syntax and doing things that you should be able to do from 115. So don't miss that. You should all be getting 50 points on that one, and then get off to a decent start on these points. No textbook, and any reading is listed on the course schedule. If you need counseling or accessibility resources, here's the links. If you're if you're having a rough go of it, counseling services can be helpful, and accessibility resources if you need extended time on exams and things like that. If you have some documented disability, talk to them, get the paperwork, and then I can help you out with things of that nature. And then AI, I'll try not to dwell on this too much, but because AI is a big deal. Like, we have academic integrity is a big deal, and we have to like my job, a big part of my job is policing this. If you violate this policy, I'm gonna do what I can to. Sounds mean that way, but do what I can to fail you. That sounds awful. I don't want to fail students, but if you have cheated in the course, what I can't allow, and especially with LLMs these days, it's very easy to just tell the LLM, hey, do my homework, do my problem set for me, and then submit that as your submission. If you're doing that, I do want to catch you. The big reason for that, there's a lot of reasons for that, but the biggest one for me is I can't let you go into 220 and 250 and go on with the curriculum without learning what you were supposed to learn in CSE116, because if you do, then you really only have one option moving forward, and that's to continue to cheat. And once you're in that position, it's extremely hard to dig yourself out of that hole, to get out of that. How do you escape that once you don't know 116? And if you're doing that, you probably did it through 115. How do you go into 220 and 250, or maybe you even get through those courses and get to your 300 level courses without knowing anything? The only thing you know how to do is to prompt an AI, which a freaking toddler could do. If that's all you're able to do, and God forbid if you actually graduate by doing that, and all you can do is the same thing of somebody who just learned how to type can do, you haven't gotten your value out of your degree. So I don't want to see you get jammed up like that. So I will be looking for that and making sure that you are learning what you're supposed to be learning. That's the big point of the AI policy, is I want to make sure you're getting your value out of your education, out of your stay in college, and not wasting your time and money, tens of thousands of dollars in 4 years of your life, and not getting anything out of it. And especially with an online course, I do have to hound this a bit because I have no in-person assessment of you. It's hard to maintain that integrity, so I have to do this by looking at your submissions, and if I think it has enough suspicious artifacts in it that I think it was generated these days anyway, mostly most people are cheating with LLMs. If I think it was generated by AI, I'll call you in for a meeting. We'll have a Zoom meeting, and you have to prove that you actually created your code. If you can prove to me that you were the creator of your code, then you're good to go. But if not, then F in the course. As you can see, F in the course, uh, and that's it. You'd have to retake 116. So the policy boils down to just these 2 points. I've tried to make it as simple as I can these days. I give lots of examples for clarification, a lot of common questions that I get, but these are the 2 big ones. You have to create your own work and don't help other students violate point 1. So don't help other students in the course cheat, like giving them your code, for example. These days, it's mostly point 1 and using LLMs. That's the primary way students are cheating. And we're getting good, at least I'm getting pretty good at catching this and failing students for using AI. Students who use AI haven't gotten any more clever, but I have, and my colleagues have. It's starting to not be a good way to get through a course anymore. We're finally catching up to be able to detect and convict on this one. So if you have been, I don't want to dwell on it too much, but if you didn't create your own work, and I'm careful with the wording here, creating your work, I don't care if you typed the code. A lot of students are like, well, I physically typed the code up, but they had the LLM generate the code, and they physically copied it over, and they thought that that was okay for some reason. You have to be the creator of the work, not the typer of the code. It has to be your creation. You had to look at the problem set, use your human brain to come up with a solution, and then code up and implement that solution that you created on your own with your brain. That's what I need to see. And you can go through all these bullet points. I ain't going to read every one this semester. If you don't plan on cheating, this is all you need to know for the AI policy. All the rest of this is mostly for students who plan on cheating, who want to pick apart the policy and, well, maybe this and maybe that. Mostly so I have something to point to. So when they do violate it, I'm like, look, I said explicitly that using LLMs is not allowed, which is this bullet point right here. Submitting any code for credit without being able to explain how that code works and explain your thought process of why you chose to write the code the way that you did. If you can't explain that, then you weren't the author. Anybody who actually wrote code can explain, oh yeah, I tried this, it didn't work, I pivoted to this, and then I did it this way because if I did it the other way, it wouldn't have, Anybody who wrote code can explain that whole thought process. If you can't go through that thought process and explain how your final solution works, I don't care where that code came from. It's not you didn't create the code. And here are just some common excuses that I hear. I'm not going to read them all, but just common excuses I hear in these meetings where students will try to give me. So I gave those excuses and the answers that I give in those meetings. If you come into the meeting with one of these excuses at the ready, my response already. And I still get these a lot. This is always the funniest one. I didn't write that code. Yeah, I know. I know you didn't write the code. Not even as an admission, but they'll be like, I don't know how that code works because I didn't write it. Yeah, okay, great. You failed. I don't understand how people think that's an okay excuse, but some students will admit, yeah, sorry, I didn't write that code. I understand the consequences. But some will be like, no, I didn't write that. Why would you think I could explain that? I didn't. Anyway, I hate those meetings. The students hate them even more. don't cheat. Don't get yourself in one of those meetings. Okay, so that's course introduction. Let's get on to some actual content finally. And unless there are any other questions, I'll be watching chat still. If you have questions, let me know. I have all these slides downloaded, but I always, out of habit, download them again. Can I just open it here? It always drives me nuts, but it has the ocular icon, like it's going to open in ocular, but if you click it, it opens in my browser. I don't want to open in my browser, so I have to open the folder, go over here, and then double click it, and then it opens in ocular. I think it's done, and I got to get my Control Shift P. Okay. And I'm not at slide 1. Okay, so any questions on the course, logistics, anything before we start rolling into some Java content? And actually talking about the course, that's the whole preamble. Hopefully you don't cheat. Oh, the one last thing I wanted to say about the AI policy. Last semester, very unfortunately, did end up failing 15% of the class for mostly, was it exclusively for LLM usage? I think it was exclusively. A few of them were like, my uncle helped me wrote that code, but I think their uncle was, Uncle ChatGPT. That sucks. Like, that sucks. But I think there's a lot more than 15% of the class using LLMs, and I hate to say it, but I think that number is going to go up of percentage of the class we fail for using it as we get better and better at detecting and doing that stuff. Just don't use it. I know the temptation is strong. You have an oracle right there that can just spit out the answers. Don't do it. Don't follow that temptation. If there's a question, kind of ties back into something we said earlier. If there's a question that you don't know how to do, like there's some pretty hard questions for the last question of some of these problem sets. If there's one that you don't know how to do, just take the 10, 15, 5, 10, 15, however many points the last one is. Just take that hit to your grade and live to fight another day. Don't bother don't bother risking the LLM and risking an F in the course just because you wanted that last 10 points. It's not worth it. It's just not worth it. And you can miss 10 points. You can miss one or two of those questions and still get an A in the course. It's really not worth it. But some students need that perfection, even if they can't earn it themselves. And I had a lot of really unfortunate, like a lot of meetings last semester were really good students. I felt bad, like I'm still going to do my job, but I felt bad failing them because they just wanted that last, couple of points to get perfect in the course when they still could have got an A without those points. And they just fell to temptation on one question, and yeah, that's all it takes. You use it once and I catch you. It's game over, unfortunately. So on that note, I don't want to dwell on the downsides. The students who are going to do that are probably the ones who aren't even here and won't even watch lectures and are, there's no reaching them in most cases. So hopefully if I stop one of you from cheating with that spiel, I'll take that as an absolute win. But yeah, the students who are going to cheat are just going to cheat anyway. If you were marked for LLM usage, would that be an F3? That's a good question. I put it in as an F1, but I think the AI office sometimes changes it. I saw one student with a straight up F last semester. I think the AI office went and changed my F1 to just a plain F, which I'm not even allowed to assign that grade anymore. Like if I try to give somebody an F without an F1, F2, F3, the hub spits it back. So I usually put them in as F1s. It, depending on when I caught them. But no, it'll never be an F3. F3 is only if you do absolutely nothing in the course. So if you've made a submission for me to catch you using LLMs, even if it's on problem set 0, you did do something in the course. So at worst, it would be an F2. But for AI, I think I'd always put it in as an F1, which if anybody doesn't know what we're talking about, F1 is like a regular F. F2 and F3 are Fs due to lack of participation. depending on how little you participated. And I don't like assigning the F2s and F3s personally. I only do it if it's really justified, because the only thing it affects is your financial aid. And I don't want to be messing with that. Like, why am I messing with your financial aid? I only care if you passed the course or not, and what grade you earned if you did. I don't like messing with the F3. But if somebody literally does nothing, registers for the course and does absolutely nothing, I'll still give them the F3. But it's a pretty rare thing. Definitely not for AI purposes. AI, if you do get caught using AI, I want you to be able to recover from that. I don't want to mess with your financial aid on top of already having to retake the course. That's just cruel, personally, I think. All right, but let's get into some content. Let's talk about Java. Hello World. Just right where every programming course should start is Hello World. So let's do it. You'll see Hello World again. Even in my 300 level course, we start with Hello World as a client and server sending an HTTP request and response. It's more complicated, but it's still Hello World. This is where we like to start. So with Java, Hello World is actually pretty complex. This is the simplest Java program we can write. With Java 25, is it now? With Java 25, they just changed the language, like earlier this year. They just changed the language, or maybe the end of last year, the end of 2025. They just changed the language, so some of this isn't required anymore. But I'm still going to go through all of the steps, because you'll still see lots of Java code in the wild that have all of this extra stuff on there. So let's still break down every piece of this, and maybe someday we'll teach the simpler way from Java 25, the new fancy way of doing it. They finally simplified Hello World. It took them 3-4 decades. They finally did it. I think it's way too late to change now, but anyway, here's Hello World in Java. Let's just break down every piece of this thing. So the first thing that we see is a package declaration. So the package declaration is what package this code lives in, which for Java is a one-to-one relationship with the directory structure or the folder structure. I always use the word directory. Some students never heard this before. They always talk about them as folders. It's perfectly fine. So when I say directory or folder, I mean the same thing. I mean the location on your hard drive of where this thing lives. And this is relative to the source directory of your project. For everything that I give you in 116, that'll be a directory named SRC, short for source, which is common across the entire industry. If you see a directory named SRC, that's where the source code goes. And relative to that directory, then we go into the package declaration. So you can find this file in a directory named source/week1. And if you go into the examples repo, I did change these a little bit. It'll be topic 1 Java basics, I think it is now. So slight differences. But that will be where you can find the code in the examples repo is the package declaration for any code. So if you're ever looking at code and you're wondering where that code lives, you look at the package declaration. If you're ever wondering what the package is, you look at the directory structure. That's going to be the package for that code. Java does enforce that one-to-one relationship. So if you have a package declaration that doesn't match your directory structure, you will get an error, and Java will say, hey, fix your stuff, because we like to be organized around here. Just make sure your packages match up with your directories. And then I'm going to create a class. So I'm going to skip the keyword public for now. I'm going to create a class named Hello World. And I'm creating a class because Java is a strictly object-oriented language, and we'll dive into all of what that means. We'll create objects and classes and all this stuff. For now, just know that a class is a container for all of your code. And in Java, all of your code has to be in a class. You need to put your code in a class. So if we're writing a Java program, we have no choice other than creating a class as a container for our code. So that's what we're going to do. We're going to create a class, and here I'm going to name that class Hello World. With a upper camel case is our naming convention for classes, so capital H, capital W. And when I create this class, I'm going to have, and advancing a slide is so laggy, uh, I'm going to have this code in a file that matches the class name. And this is another thing that Java does enforce. Your class name has to exactly match the file name for that code. So I have a file here that's creating a class named Hello World. That means that this code has to live in a file named helloworld.java. If it doesn't, Java's going to let me know about that. It's going to say, hey, again, we like organization here, and you have to have your class name match your file name. And when you have a file, that file can only define one class. That's the whole purpose of a Java file, is to create one class. So this helloworld.java file, its whole purpose is to create the Hello World class. And combining that with our package declaration, just looking at the code, we know that this code lives in a directory named source/week1, and then in a file named helloworld.java. So looking at any Java code, you can figure out where that code lives. Then we have our main method. You'll hear me say this a lot throughout the semester, every Java program since the dawn of time has always started with a main method. Every Java program starts with a main method. So if you want to run a Java program, you don't just like run a program. Like in Python, if you're coming from 115, you write a Python file and it's a script. It'll run your code starting at the top of the file and just run all of your lines of code sequentially. That's not how Java works. Java will always start at a main method, and that's the entry point for your program. So if we were going to write a Java program, we got to have ourselves a main method. And a main method looks like this. It has to have a lot of components, aside from what I mentioned of Java 25. Did simplify this a bit. I'm going to still teach it the old way. I think Java 25, you just need void main, and then you can have an empty argument list. I believe that's how far they simplified it. But we're going to go through all this, every part of this. So here, and I'll give a brief overview of everything. By the time we're done with the course, actually by next Tuesday, I believe, right? We'll have a good understanding of all of these keywords: public, static, void, and this string array. We'll talk about all of this stuff, eventually, most of it next Tuesday. For now, I just want to give a brief overview, a very brief one-liner on each one of these things. For these, we have the keyword static. Static means that we can call this method without doing extra work. We're going to see on next Tuesday, the extra work is creating an object of a type defined by a class. And we'll talk about all that stuff, and that's how we can do non-static methods and call those. If we don't want to do any of that, we don't want to think about objects yet, which we don't, then we're going to make our methods static, which means we can just straight up call this method without doing anything extra. No objects created of those classes. Void means this method doesn't return anything, and we'll talk about that a bit more when we talk about strong typing and methods later today. Main is the name of the method. So this is similar syntax to most programming languages. We have the name of the method here, which has to be main, all lowercase, M-A-I-N, all lowercase letters. And then we have the parameter list, which takes one parameter named args, and it takes an array of strings, which would be our command line arguments, which is admittedly something that we're not going to use in 116. In 220, you start using command line arguments. In 116, we're not going to use them, but this is the syntax for an array of strings. Now your main method, yes, and then public means that you can call this code from anywhere without having to do any extra, not extra work, but you can call this code from anywhere. There are other, these are called access modifiers. There are other access modifiers, private, protected, and then the default if you just don't use any, that limit who and from where you can access the code. Public just means it's a free-for-all. Everybody gets to call this code. If we're going to have a main method, it's got to be public, and the class itself has to be public. so that Java can access this main method, call it, and actually start your program. So a main method's got to be public, and our classes are all going to be public as well. So we can actually use that code from other classes, from other files in our project. So that's our main method. Our main method has to have all of these ingredients: public, static, void. It has to be named exactly main, all lowercase. It has to take one parameter of type string array. And the one thing that can change this args is a variable name, and you're welcome to name your variables whatever you want. By convention, we usually call this args. Across languages, it's just convention to call, if it's your command line arguments, we just call it args. But technically this could change and you still have a main method. All the other ingredients, public, static, void, main, string array, all of that has to be there or else you don't have yourself a main method. And if you don't have a main method, for example, you name this with a capital M, that's not a main method anymore, and the difference is that you can't run it as a Java program. Java won't recognize it as a main method, so it's no longer able to serve as an entry point for your program. So you have to have all of that to be able to run this as a Java program, which is why we don't use Java in 1.15. We actually used to, but that's why we don't use the Java in 1.15 anymore, because the equivalent program in Python is print hello Python. That's it. Like, that's all you do day one of 1.15. Much, much simpler. With Java, there's just so much stuff that we have to talk about for our very first Java program. In most classes, they'll just say, ignore most of this, and that's kind of what I'm doing as well right now. We will get to it all eventually, not today. But you basically ignore most of this and just say, oh, trust me, you have to have all this stuff or else you don't have a Java program. And then you start learning Java. Like if you took Java in high school, that's what they usually would do. That's what they should do, at least, in my opinion. So that's a lot just for Hello World. And by the way, we haven't even printed Hello World yet. We still got to talk about the code. We haven't even gotten to the code. So there's a lot of moving pieces just for a Java program. Luckily, IntelliJ has us covered in a lot of cases here. IntelliJ is, I forgot to mention this going through the intro to the course, but IntelliJ is the IDE that we I don't want to say endorse, but support. There's the IDE that we support in CSE116 and recommend. So if you use IntelliJ, everything with the course is made to work in IntelliJ, and that it will work in IntelliJ. And if it doesn't work in IntelliJ, Miriam and I will support you. Come to office hours. If you're having issues with IntelliJ, we'll help you out. We'll help you get that all sorted. You are allowed to use other IDEs. You can use whatever you want. You can use TextEdit if you want. You can use whatever the hell you want. I don't care. But if you have issues that are caused by an editor that's not IntelliJ, Miriam and I aren't necessarily going to help you out. If there's no queue in office hours and we're familiar with your specific issue, then maybe we might. But there's no expectation of support for other environments if you're avoiding IntelliJ, because we did a lot of work. I've done a lot of work making sure everything works in IntelliJ. To do that in another IDE, like a lot of people like to use VS Code. VS Code doesn't really play nice with the way we have things set up for IntelliJ, specifically running the tests. I already had somebody with this issue this semester. Running the tests in VS Code is VS Code likes a very specific structure for the programs, and if you don't follow that structure, it doesn't like to run your tests. Now, without a whole bunch of work behind the scenes, you can go into the command line and run them manually with a lot of pain and suffering, but you can get it to work, but it's not worth it. Just download IntelliJ. You can right-click the test and click Run, and it just runs. So I really recommend IntelliJ, but if you want to go through that pain and use VS Code or whatever else you want to run, go for it. You want to use Eclipse for whatever reason, go for it. But just know that we won't give support for that if you have issues specific to your environment. If you're using VS Code and you have questions about the code and about the concepts of the course, we're of course still going to help you with that. But if you have an issue like I'm having trouble compiling in VS Code specifically because of VS Code, we're we're not always going to spend our time on that. There are better things that we can all be doing. You can click download IntelliJ and solve that problem immediately. That's the solution that we have available for you. Okay. Anyway, so in IntelliJ, you can type main. If you're in a new class with no code in it and you type MAIN, then there will be an autocomplete option. You hit enter and it'll write public static void main string array args. It'll do all of that for you. So those are all the components that you need for a main method, but in IntelliJ kind of just has you covered and you don't have to memorize all of that stuff. I think the new main, the new shortcut, will do the new way of doing things. So unfortunately, this is getting a little sloppier now. So if it doesn't add all of this stuff for you, you might have to add more. Is that even true? I don't think that's even true, actually. That you might have to add more because we're not running Java 25 in Autolab. But also, Autolab's never going to run your main method, so I actually think that's fine. I don't think that would cause issues. But if it does, add your public static void main string arrays, add all the extra stuff. And now we can write some code. After all of that, an hour 15 minutes into the first lecture, granted a lot of that spent talking about the course itself, but after all of that, we can finally write some Java code that runs. And this itself has to be more complicated than it needs to be. Again, Java 25, let's just do print line. We can finally omit the system.out. But in the old ways, and you'll see a lot of code that looks like this, including all the code I'll show you this semester, is system.out.println is our equivalent to print in Python. This is going to print whatever string you give it, followed by a new line character. If you do print without the ln, it won't have the trailing new line character. So this is how we print in Java. Or in IntelliJ, you can write sout, and it's going to type all of this for you. It's going to give you the entire, it's going to give you this whole line. So you don't have to remember system.out.println. And then you finally run this program, and it's going to print hello Java to the screen. And every statement in Java ends in a semicolon. Not much to say about this, just don't forget your semicolons. But if you forget your semicolons, IntelliJ will be like, hey, you forgot a semicolon on line 6. You should probably put one there. And it'll give you a red underline, a squiggle right here, and you hover over it, it says you should put a semicolon right here. It used to be a big deal remembering your semicolons in programming. It used to be a big pain. With modern tooling, modern IDEs, it's really hard to forget a semicolon. Like, you can forget one, but the IDE just slaps you in the face and says, hey, you forgot it. Just put a semicolon right here. And it's easy to recover from that mistake very, very easily. Okay, so I think right here, and if we don't get through we might not get through all the content today, but Thursday, some of it can spill over Thursday and we'll stay on track. But I do want to, since we don't have lab, usually we have a lab that goes through IntelliJ setup. I do want to do some IntelliJ setup right here now that we've seen our very first program. I'll do this pretty quickly, but let's do the examples repo, and let's get this example in right here so you can get started on things right away. The examples repo, what I'm going to do is go to the repo and copy this link. This is the same exact thing you'll do for the problem sets. When you go to problem set 0, there's a GitHub link for each problem set. It's going to look very similar to what I just did. And then you go to code and copy this link, and that's the URL for that repository. Repository is a place on GitHub where we store all the code, so I can share code with all of you. Makes it convenient to be able to do that with getting this link really easily. When you go to download IntelliJ, just make sure you download the one for your version. I'll accept cookies. Download the one for your operating system. The website's pretty good about choosing your operating system for you. I'm on Windows right now, so it's selected Windows. If you're on Mac OS, make sure you get the one for your design. If you have a Mac these days, it's probably Apple Silicon. But if you do have an older Mac that's still Intel, just make sure you're getting the right one for your system. Same with Windows. If you're on a Windows ARM machine, make sure you're getting the Windows ARM installer. So make sure you're downloading the right one for your operating system. And then once you download that, of course I already have it downloaded, so let's jump to IntelliJ. You'll see something like this. And when you're at the initial splash screen, you want to go to Clone Repository, and you're going to paste that link. And IntelliJ does most of the work for us here. You're going to paste that link. I have one extra step that I have to do. I'm already going to have a directory where I clone this named class example code. So I'm going to put a 2 here. Actually, I probably already have a 2 from a previous lecture example. But I'm going to click clone, and that already exists. So let's go 3. Probably already have a 3 as well. Nope, I don't have a 3. And that's going to download all of that code from GitHub and download it onto my machine. So all of the code in the examples repo is now in my IntelliJ, even if it was already, but now I downloaded it a third time into my IntelliJ. Same thing with your problem sets. You do the same thing. Download the well, you already have IntelliJ downloaded by then, but go to clone project and paste that link, and then you'll get all that starter code for each problem set as well downloaded into IntelliJ. If you're already in a project, say you're done with problem set 0, but you open IntelliJ, it opens right into problem set 0. You can go to your menu, go to Git, and clone, paste your link, and then it's the same thing. If I want to do a 4 here, I can download this a 4th time, and you can download a new project when you're ready for the next problem set if you don't want to go back to the splash screen. But you also saw me go back to this splash screen by going to close project. You can get back there that way as well. When you do clone a repository, you'll see a bunch of progress bars along the bottom. Right now it's for some reason taking a while to clone, which I don't know why. Yes, I would like to open it. And then you'll see a few more progress bars. They go by pretty quick. Oh, and they're all gone. I can't even explain them because they went by so fast. When you do this, what's happening is IntelliJ is reading this pom.xml file, and this pom.xml is downloading any dependencies that we need. For our purposes, it's, I still have Twitter4j, and, yeah, because this is the examples repo. Twitter4j is an old dependency we used to use previous semesters. And the big one that we use is JUnit. So you see JUnit right here. This does not come with Java. This is an external library, but it's downloaded through the pom.xml. So if you have any issues running JUnit tests, that means something might have went wrong there, but it's pretty automatic. It's pretty free these days and works pretty darn well. And then when I will go to run my code, sometimes you'll see this up here. You need to download a JDK first. So I'm going to go to configure, and you won't have any JDKs available by default. So you go to download JDK, and whatever the default is usually fine. The pom.xml, actually let me just do the default and see if this is going to work for us. In the pom.xml, we have it specified as 25 right now. We have to update it every time a new version comes out, and apparently 26 came out since that was my default. And it's downloading. We can see the progress bar down here. Oh, I am going to have to make this bigger, ain't I? Can y'all see this fine? I have to adjust my settings for the summer. 20. Let's go with 20 font. Hopefully that's better. So now that that progress bar finished, downloaded the new JDK, and I'm ready to be able to run some code. I get these green go buttons here. I can also right click on a file and go to run, which is the one I'll choose to do here. And that should compile and run my code. Yes, I want to allow the JDK to run. Windows has got to protect me. And we get Hello Java printed to the screen down here. So we got our first program running. We cloned a repo. A lot of steps there. They go by quick. Obviously, you can rewatch the video, and you can come to office hours. We can help you out, get you set up with everything. But I do got to get back to slides, so let's jump back over here. And if there's anything else, I can jump back to IntelliJ if you have any quick questions. But I did want to get that demo in. We got it in there at least. And talked about IntelliJ setup. Usually we have a whole lab. We have a 2-hour lab where we're setting up IntelliJ and multiple TAs walking around with students and getting everybody set up. So we're doing a summer abbreviated version of that. Let me know if you have questions. Post on Piazza, come to office hours, or ask right now. Okay, so let's get on to some more content. Where are we? We have, and I always get tripped up in the first few lectures of the summer. We go till 11 to 1:30, 2.5 hours. Yeah, 1:30. We go till 1:30. So I got some time. Let me... Oh my goodness. I'm going to set an alarm for that even, because just in case I lose track of time, I want to make sure my phone's going to tell me to stop talking, or else I'll go like half an hour over or something. I don't want to put you through that, I guess. Okay, so let's talk about, or else I would just go on a run and do the whole course in one day. Actually, I would just rip through it all. But let's do this, and then you'll be overwhelmed. Of course, you could rewatch. It doesn't matter. So let's talk about variables and methods. And I've been talking about methods. I said a main method was the one that I said a bunch of times already. Main method, main method, main method. You might not have heard the word method before. In Java, we have methods, and we don't have functions. But methods and functions are mostly interchangeable. If every time I say method, you hear function, and you take everything you know about functions and apply it to methods, you're going to be just fine. There is one subtle difference to methods, and it's the context, the keyword this, stuff that we'll talk about on Tuesday. I'll mention it when we get there. But for now, just know that Java doesn't have functions, it has methods. A method is something that would be a function that we normally know as a function that is defined within a class. Since Java, every would-be function is defined inside a class, we only have methods. So everything in Java is a method. No, we don't have functions. We do have something called, well, it doesn't matter. Some called lambda functions, but they're really actually not functions. They're objects, and it doesn't matter, though. It doesn't matter at this point, unless you're interested in here, and I'll be happy to answer questions. But we only have methods. So let's talk about methods and variables in Java. And a lot of this you're going to know from 115, or whatever your CS1 course was. If you did AP CS in high school, or you transferred from another university, it doesn't really matter where you came from. You're going to know a lot of these concepts, the assignment operator, declaring variables, defining functions, which are now going to be methods. Like a lot of these things you'll know. So I will focus on the Java specific differences that are new to Java. And especially if you're coming from our 115, the things that are new from coming from Python to Java. If you're coming from anywhere else, our CS1 course is taught in Python. So I will emphasize the differences between Python and Java. a bit more. If you came from a language that say has strong typing, the next thing I'm about to talk about, then yeah, you can chill a bit. You already know that concept. But most of our students at UB won't have heard of that yet, coming right out of 115. So Java is strongly typed. This is the first and biggest thing that we need to know about Java, and this will permeate throughout the entire course. Talking about typing is just a huge thing that will permeate through everything that we do. And it's probably, I would say, the biggest reason why we teach 116 in Java is so we can talk about all of the things that we need to talk about because it's strongly typed. It'd be very hard to talk about the concepts like inheritance and polymorphism in a language like Python. Wouldn't really work out so much. But anyway, what does strongly typed mean? It means every single variable in Java needs to have an explicit type. So this variable that I named num and assigned a value 2.4, this num, I can't just create a variable named num. I have to create a variable named num of a specific type, and the type for this variable I'm specifying as double. So I'm saying I'm creating a variable of type double. I'm going to name it num, and I'm going to assign it the value 2.4, and that's a statement, so I end it in a semicolon. When I declare a variable of a specific type, that variable can only ever store values of that type. So this variable num can only ever store a double, which a double is a numeric value that can have a decimal portion. This variable num can only ever store a variable of type double. If I try to say num equals some string, that's going to be an error and my program won't run. That's going to just break everything. I'm not allowed to reassign num to a value that is not a double, with only very, very few exceptions. I can assign num a value that's an integer, and then Java will convert the integer to a double without loss of precision. We can just do that. That's fine. But I can't assign like a string, a value of type string to num. It's not going to let me. Num can only ever store a double. That's what strong typing means. I have a variable that is a container for a value of type double, and that's it. That's all it can ever store. So that's, in a nutshell, is strong typing. That's like all you need to know. Everything else is derived from that. I'll still go through everything, of course, but there are lots and lots and lots of implications of that. But that's the core of it. That's what strong typing means, is our variables all have types and can only store values of that type. So this whole line, I'm declaring a variable named num. I'm assigning it the value 2.4. And that variable is of type double. And whenever you reassign, so there's a variable declaration. We're declaring a variable. When we create a variable for the first time, we specify its type. When we're reassigning the variable to a new value, like we do in the next line, we do not specify its type again. We only specify its type when we're declaring the variable, which declaring and reassigning, those kind of get blurred in Python because the syntax is the same. In Python, you'd say num equals 2.4, num equals multiplied by 2. The first line you declared the variable, the second line you reassigned it, but it's the same syntax both times. In Java, we do have to be aware of the difference between declaring a variable and reassigning a variable and using a variable. We only specify the type when we declare the variable, which is where we create the variable for the very first time. We specify its type, and then its type is known for these three other usages of num in this method. The type has already been declared as double. We don't have to specify it again. And if you try to specify the type again, Java will think that you're declaring a new variable, and then it's going to give you an error because you're going to try to declare two variables with the same name. And it's going to say you can't have two variables with the same name and cause issues. So we only specify the type when we first declare a variable. And we have our first method. The method definition and the method call, a lot of this is the same in any language that you would have taken for a CS1 course. Calling the method, we specify the name of the method and then an argument list. And then defining the method, we have the method name and then the parameter list. So the Java specific stuff is pretty much all the rest of it is public static. I'm going to stop talking about public static. Every method that we have for the first part of the course until we get to problem set 1 and next Tuesday's content. So really just for 2 lectures in the summer. But it's 2 weeks in the regular semester. But for 2 lectures, the first 2 lectures, in problem set 0, every method is going to be public and static. Public so we can call the method from anywhere, which is going to be from our test cases for the problem set and my other test cases in AutoLab. When I'm grading your code, I need to be able to call your methods, so they need to be public. And then static, meaning we don't have to create objects or worry about objects yet. We'll worry about that next week. So everything will be public static just so we can call these methods without having to jump through a whole bunch of hoops and without having to do a bunch of extra stuff that we'll talk about later in the course. So for now, we're kind of pretending that our methods are just functions. Public static methods behave just like your functions in Python or any other language with functions. It's strict input-output behavior. You give it some parameters, you return some value. That's, if you don't know where you're headed, you might think, what else would you do? But we'll see. We'll talk about objects and state starting next Tuesday. So I'll stop mentioning public static. Just for the first week, everything is going to be public static. That's just going to be the natural state of things for a little bit here. The next thing is another new Java thing, coming from Python at least, is the return type. Every single method you declare in Java must have a return type. And that return type is a very rock-solid contract that you're signing with Java, saying this method will return a value of this type. So my multiply by 2 method is going to return, has a return type of double, meaning that it will 100% of the time return a value of type double. And it has to return a value of type double. And you have to specify the return type. So Java will always want this for every method, and you do have to hold to it 100% of the time. Breaking this contract will break all of your code, so Java just doesn't let you even think about breaking that contract. So with this method returning a value of type double, that means I can safely make this method call. I know that this method call will resolve to a value of type double, and I'm assigning its return value to a variable of type double, and Java's going to check to make sure all of our types match up. So since it knows this method will return a double, it's going to say, yeah, you can safely store that value in a variable of type double, and all the types check out. That's what strong typing is doing for us, is it's letting Java do all this checking for us to make sure that we don't have any obvious bugs in our program where we're mixing types. In Python, you just have issues like this. The Python isn't going to check your types at all. It's just going to try to run your program, and if you mix up your types, if you have the wrong types in the wrong places, the program just crashes. So Java's doing a lot of work to help us have fewer bugs in our program, which is much, much appreciated, especially when your programs get large. A large Python program is very hard to keep track of all of your types. Eventually you're going to make some mistakes. With Java, the language itself makes sure that we don't have any type errors. And the biggest one you probably saw in Python is when you're trying to print a string to the screen. You're trying to do print, and then as a string, the value of x is, and then concatenate x, the variable of type int, to that string. And it says, you can't concatenate a string and an int. You're not allowed to do that. And you go, oh crap, I got to put my str and then parentheses around my value to convert it to a string first. You can't make that mistake in Java, because Java's going to have all this strong typing that's going to make sure you don't write code like that. Or if you do, it'll say, hey, just so you know, I think you got an issue over here. You're trying to concatenate a string and an int. That's not going to work for you. Which, incidentally, I do on this very slide. Which, since I brought it up, I got to talk about it here. I do on this very slide, I do concatenate a string with a double. Java's string concatenation operator is very powerful, very sophisticated. What it will do is, if you have a string and then plus, it'll treat this as a string concatenation operator, and then whatever the other value is, it will automatically convert it to a string for you. So we actually don't even have that same issue that we had in Python. We don't have that issue in Java because string concatenation is so powerful in Java. It'll automatically do your type conversions for you. Okay, so now we have our types, our return type, and our types are all matched up. And then for our parameters, and we actually already saw this in the main method, and I intentionally didn't talk about it then, but our parameters are variables. All variables in Java are strongly typed. Therefore, our parameters in Java have to be strongly typed. Every time you have a parameter in a method, they all need to have their type specified. So I'm saying this method takes a parameter of type double and will return a double. In the problem set language that I do in PS0 especially, I would word this as write a method named multiply by 2 that takes a double as a parameter and returns a double, and the value it returns is the input multiplied by 2. That would be the problem set description of this method if this is what I wanted you to write in that problem set. So this is taking a parameter of type double. So when I call multiply by 2, when I call this in the main method, I'm giving it the value of num, which is an expression that's just a variable. So it resolves to whatever is being stored in that variable, which is 2.4 as a double. So I'm giving multiply by 2 a double, which matches its parameter type. So Java's going to be happy about that. Java's going to say, okay, you told me this method takes a double. You called it with a double. We're cool. We're good here. We're good. But every parameter also, since it's a variable, needs to have its type specified. And then the actual code of the method, there's nothing really special here. I could just say return input times 2. I split it into 2 lines just so I had an extra variable declaration since we're talking about variables. We can create variables inside our methods. So I have a local variable x of type double being assigned whatever the parameter is multiplied by 2. And then I'm returning x. So since I return x, and x is of type double, and I have a return type of double, my return types all match up. So everything's good there. And this method only has one path of execution. It's going to execute these 2 lines every single time it's called, and that results in returning a value of type double. So we're all good. Our return type is checked out. A code block in Java is defined by 2 braces. So everything in between the braces is part of that code block. I have a code block defining this method definition between the 2 curly braces. And inside those braces, indentation does not matter. So coming from Python, where indentation was king, here indentation doesn't matter. You should use proper indentation just for readability, legibility of your code, but the language itself doesn't care about your indentation. It cares about the braces to define code blocks and semicolons to define the end of a statement. So Python doesn't use either of those. Python uses indentation for both new line characters for the end of a statement, and then indentation for a code block. So a bit of a difference coming from Python. And if you have conditionals, we'll talk about conditionals. Today we should. It might spill over a little, but potentially today. And once we get to conditionals, when you have multiple paths through your method, if you're returning inside of your conditionals, your if or your else ifs, every single possible path through your program has to result in returning a double. And if it doesn't, then Java's going to be mad about that. And that can cause some... Actually, I haven't seen that mistake in quite a few semesters, but it can cause some issues if every single path doesn't lead to returning. So for example, if you say if return a double, else if return a double, and then nothing after that, Java's going to say, well, what if both the conditions are false? You don't have an else statement, and you don't return anything after your if. So Java would not like that, because if both conditions are false, you go to a non-existent else, and then you don't return anything. So every single path through your method must result in returning a value of the appropriate type. So when we call this, this does what you would expect it to do. There's nothing new for Java here that we haven't already talked about, especially since I talked about the string concatenation ahead of schedule here. But num is being assigned the value 4.8, the result of this method call. Then printing to the screen, new num, and then I have my space. I didn't have that on the previous slide. New num, and then 4.8. So that's what's printed to the screen. New num colon space 4.8. And then we have one extra method here, this method y. It's named y because why would you ever do this? You would never write a method like this unless you're teaching a lecture and you want to talk about the void return type. So I'm calling this method y, which has a return type of void, which is our way of saying this method doesn't return anything. So you have to have a return type, but that return type can be nothing or void. So if your return type is void, it just says your method doesn't return anything, and it's called for its side effects. In this case, the side effect is printing to the screen the string I return nothing. You notice that the main method has return type void, and the main method isn't called for any return value. It's called to start your program, so we don't need any return value there. In other languages, you would return an int. You know what? I don't even want to talk about that. Or do I? Java does return an int, but it's behind the scenes. We don't have to return an int, but we still need that status code for the operating system. But Java hides the details of that, and we don't have to care about it. And then once we reach the end of the main method, that's the end of our program. So as soon as you hit that closing brace of your main method, program's over, memory's cleared up, everything's done. So Java is strongly typed. We just talked about that. We went over our variable types, parameter types, and return types. We have to have types all over our code. But I only talked about one different type, or not even different, one type. That whole example that I just went through had doubles. Technically, we saw string and string array. But let's talk about a few of the common types we'll use. There are 4 types that are going to get us through quite a bit of the semester. And then we'll start combining these and creating objects. We'll talk about that next Tuesday. But these 4 types are going to really get us through quite a bit. So first, double. I briefly talked about this. I just said it's a number with a decimal portion. Actually, I'm not going to expand on that very much until we get to the testing lecture. When we talk about testing, there's some complication with doubles. We can't always store a number exactly in a double. There will be some truncation, which we call double truncations or truncation errors, because usually they do often create errors in our code because we don't have exactly 2.4. Actually, I think 2.4 we have exactly. But some numbers can't be represented exactly in a double. Some we'll have to worry about when we talk about testing. But it's a number that can have a decimal portion. That's the one-liner for it. A string is just like a string that you would work with in any other language. A string is a sequence of characters, and notice that the type string does start with a capital S, while these other ones start with lowercase letters. Any type that starts with a lowercase letter is a primitive type. S with a capital letter is going to be a class type. We'll talk about the differences between the two when it becomes relevant. But yeah, we'll just talk about it when it's relevant. Actually, it will be relevant later today in a little bit. So we do, in CSE116, we treat string as though it were a primitive type in our memory diagrams. We will pretend that these string variables work the same way as our primitives, meaning that they are storing values directly, whereas most of our class types will store references to objects on the heap. And if you came from 115, just like your list in dictionaries were references to objects on the heap, actually all types that start with capital letters, these class types in Java, are references to objects on the heap. String is not an exception, but we do pretend that it's an exception to make our memory diagrams simpler, or else our memory diagrams get way, way too complicated for no actual educational gain. So we do pretend that. But for now, at least notice that that's a capital S, and that will become pretty relevant for other types that are in capital letters. Ints are whole numbers, so these are numbers, but they cannot have a decimal portion. Uh, they are allowed to be negative. Same with doubles, they can be negative as well. And the big thing to know about integers is that if you have an int divided by another int, the result has to be an int. You cannot divide two ints together and get a double as a result. The result has to be an int. And the way Java reconciles this is if there is any remainder, it is just removed completely. So if there would be a decimal portion, the decimal portion is just truncated. So 6 divided by 4, you would expect it to be 1.5, but the 0.5 is completely erased, and you only get the whole number result of the division. This is effectively taking the floor, so if you have 99 divided by 100, the answer is 0.99, the 0.99 is truncated, and you just get the 0. So something to always be aware of if you have two ints. If you don't want integer division, you would have to make sure one of the two values is not an int. And then Boolean, I don't have much to say about this. It's either true or false. Any language you've learned, you've talked about Booleans. True or false, for what it's worth, it's lowercase t, lowercase f. In Python, it was capital T, capital F. All right, and we're going to do our first memory diagram. I'm going to take a very brief break. I'll be back in 1 second. Just give me 1 second. And we're back. All right, so we want to do our first memory diagram. Right now, we're doing it. So our first memory diagram, I'm going to go through a slightly modified version of what we just saw in the slides, mostly so I can get everything on one slide, but also like little things adding a parameter to the Y method, just so I have a few more things I get to talk about in the memory diagram. In the rest of the slides, I do have a memory diagram laid out. I used to do memory diagrams in the slides. I left them there, so if you do want to click through the slides and have my commentary on the memory diagram in slide form, I just left that there for you. But I'm going to do these live in the tracing tool, so I'm doing them the same exact way that you're going to do them in your traces. So I'm going to grab this code from the repo in this variables functions in the topic 1 Java package. You can see I'm in a directory topic 1 Java, so the package is topic 1 Java. Matches up. Variables functions is the class, so variables functions has to be the file name. Like we talked about earlier, we have everything matching up according to that. So let me jump back to the browser, go to course website. I'm going to go to the memory diagram, the tracing tool, and I'm going to go to the practice side of this. Actually, you won't ever go to the instructor side. Why would you? The instructor portal. When you do the traces for your exams, I'll email you the 4 links for the 4 traces, and it'll take you directly to a trace with the code already pasted down here. You already have the code right here for the midterm and final. So I'm going to switch this, set this up. Java, I want was it F11? Full screen, hide the toolbar, resize. Oh, I don't have to resize. And let me know if that size is fine. It's hard to tell. I feel like it's. I'm not downscaling anything. I don't know why it seems to be coming out a little blurry. But I don't know how that looks on y'all's end. But if it's tough to read, let me know. I can make this make the font bigger. Actually, for this one, I can just make it bigger now. There's no point in holding out on you. I don't need this much room. Let's do this. We're not going to need the heap. I'll leave the heap there, but we're not going to use the heap for this trace. And I will go through, if you did take 115 here, I am going to do a bit of review. Not everybody has taken 115, so for some of y'all, this will be the first trace you've ever seen in your life. So I will explain every part of it, though some of it I might go decently quick through. But let's do this. And how are we doing on time? We got 35 minutes. I want to get through this trace and at least some of the next slide deck. I think we got that. I think we got it. So very first thing, we're going to print to the screen. Whenever we, actually very first thing, so we have 3 methods in this Java program. When we run a program, we always start with the main method. That's where a program starts. The open brace of the main method, we go to the first line of code, first statement. That's where things always start. So the very first thing that happens is we're printing I can print to the screen. For that, we go to our I/O section. And this is where we put everything that's being printed to the screen. So I can print, exclamation. That's the first thing that happens in this program. This gets printed to the screen. Next, we have our first variable declaration. Actually, I forgot the very first thing that happens. The very first thing that happens, every Java program always starts with a main method. So we have a main stack frame. If you're coming from 115, in Python we had the global variables section, which aren't really globals, but whatever. With Java, every single program starts with a main stack frame. So we have a stack frame for our main method, and that's where the variables for the main method will go. Everything is in a stack frame. Every variable on the stack is inside of a stack frame. There's no global section. When I switched from Python to Java, Python will have that global section. When you switch to Java, it does better syntax highlighting for Java, but it also gets rid of that global section because that does not exist in Java. So I have my main stack frame. Every method call corresponds to a stack frame. When a method is called in a program, there's a space on the stack that's allocated for that method call. We get the space for that method call. Well, that's a bit of a misspeak, but it's not really relevant to 116. As we get this stack frame, and then all the variables that are declared locally inside that method are declared inside this stack frame. And then when the method call ends, the stack frame is destroyed and all the variables in that stack frame are removed from memory. So the first thing we have in the main method is a variable named num. We have our name column and our value column, named num being assigned the value 4. So that goes into our main method's stack frame on the stack in memory. The next thing is num2 being assigned the value 2.4. num2 is the value 2.4. And notice when we're adding variables in our memory diagram, we don't specify the types. I'm not saying a variable num of type int or num2 of type double. Nowhere in our memory diagrams, in our variables for our memory diagrams, do we specify any types for reasons. I should expand on that at least a little bit more. Mostly because it doesn't matter. When we get to polymorphism week, I will dwell on this and make a big emphasis, a big point of it. But the types don't matter at runtime. And when you're doing a memory trace, what you're doing is tracing through what the program does at runtime, as opposed to compile time before your program runs. Java's going to check all your code for any errors. That's the only time where strong typing matters, which is also why Python can't have strong typing, because Python's an interpreted language, not a compiled language. but we're getting into the weeds at that point. The short answer, there was no question, but the short statement for that is we don't put the types in our memory diagrams. That's for a good reason, because it doesn't matter. And then num3. So strings technically are objects on the heap, and they're immutable in Java, and they're weird. Strings behave very weird. What we're going to do to address that is ignore that they're weird and pretend that they're stored by values. So when we have a string, we're going to put the value of that string as though it were directly stored in the variable. This is not how it works under the hood, but it is how we're going to simplify things in 116 so we don't have a lot of complexity in our strings. We would have a total of 1, 2, 3, 4, 5, 6, 7. Did I miss any? 7 different objects on the heap for our 7 different strings that appear in this program. And I'm not doing that. Actually, would it be... Actually, I think it'd be 9, because num3 would have to be converted to a string and then concatenated. So I think it'd be 9, num3 and num2. Anyway, we're not putting you through that. We're just going to pretend they're stored by value. Then we don't have to worry about all the object creation that's happening with these things. And then finally we have not finally, but we have num3. Beautiful named variables. 6 divided by 4, you would think would be 1.5, but since these are 2 ints, it'll be just 1. So remember, integer division is a thing, and then bool with the value true. We're going to print to the screen. This would be, I believe this would be 3 different string objects on the heap you'd have to create to actually do this properly. To just do a single print statement, that's not something, again, not something I'm going to put you through. And then the value of num3. Whenever I have to reconcile a variable when I'm doing a trace, I don't like looking at the code. Then I have to rethink, oh, 6 divided by 4 integer division. I don't have to do that. I'm always going to look at the variable. So num3, I'm going to look it up. It has the value 1, and I don't have to really think all that much. I am num3, value 1, because I'm looking at it here. And that's exactly what the computer is going to do when you're doing your traces. You are doing exactly what the computer does. There's no imaginary stuff aside from simplifying strings that I mentioned. But there's no imaginary stuff. When we're tracing code, we are doing exactly what the computer is doing when it's executing your code. And what the computer will do is look up num3 in its stack, look for the symbol num3, and then look at its value, which is sitting right next to that variable. So that's what I like to do when I'm doing my traces. It limits my mistakes and it's more accurate. And then we have a method call. So whenever you have a method call, you have a new stack frame. So I'm going to click the Create Stack Frame button. And the name of the stack frame is going to be the name of the method being called. So multiply by 2, DOW. And we're going to set the return variable. So this method call is returning to the variable num2. So I'm setting my return variable to num2. And that's a nice visual indicator of where the return value is going to go when this method is done being called. And I have one parameter. The first thing we do, well, I already did a few things, but when we create a stack frame for a method call, we're going to put the parameters on the stack frame. So I have a parameter input being assigned the argument num2. And again, I'm not looking up here. I'm looking up here. Num2 is 2.4. Happens to be the same in this case, but often it's not. Often you'll miss, if you look at the code, you'll miss some reassignments sometimes. So I like looking at the stack. And now that we have our parameter assigned to our argument, then we're ready to run this method. We're ready to go through the method call. And notice, so the main method does have an argument. Technically, args is in the main stack frame, But this is another simplifying thing that we do in 116. Since we never use this string array of args, we're not going to trace that. We don't have to trace that. If we did, you have to put args and then a reference, create an object on the heap for an empty string array. And again, there's no point in making you do that every single time. For every single trace, that'd be your first step. It's no point. No educational value to be had there. It's just tedium. So skip it. And we're ready to run this method. We declare a variable x. We're going to take input, which is 2.4, multiply it by 2, so we get 4.8. And we're going to return x. So when we return, our method call is ending, which means our stack frame is being removed from memory. So the multiply by 2 stack frame, along with its variables input and x, are being removed from memory. They no longer exist in memory. Now for our memory traces, for our tracing diagrams, which memory trace and tracing diagram I use interchangeably, by the way. If I try to stick with just one, but I slip up. We've changed the names of them a few times, and just all the names get mixed in my head. If you hear me say either one of those, I mean the same thing. So when it's removed from memory, we don't erase it from our memory trace, because we are tracing through everything that happened in memory during the execution of the program. And when our trace is finished, we want all of that history. So even though this stack frame is removed from memory, and the next stack frame, the Y call that we're about to do, that will use the same location in memory as multiplied by 2 used to occupy, and it will overwrite everything that was there. That's what's actually happening in memory. For our traces, we're just going to cross them out so we still have the information there. Because when the program ends, the main stack frame is removed from memory. So if we didn't cross them out, if we actually erased them, every single submission that you have for your traces would have an empty stack. Every program ends with an empty stack with absolutely nothing on it. So there's nothing really to grade. Like, how do I grade that? How do I make sure you actually trace through everything? That'd be silly. So we just cross them out. But when stack frame is crossed out, it is actually gone from memory. And what it did was return x. X was 4.8 when it still existed in memory. So we're going to update the value of num2. To do that, we don't just change the value. We're going to click this plus sign, cross out the old value, and put in the new value, 4.8. So we never, again, just like why we cross out the stack frames, we want to preserve all of the history of what happened throughout the execution of this program. So we're going to cross out 2.4 to say, okay, it used to be 2.4, but now it's 4.8. Now looking at the final trace, we'll be able to see that num was 2.4 and was updated to 4.8. So we preserve all that history. We can see everything that happened in this program. And then we get to another print line, new num2, new num2, colon, space, and then num2. I'm going to look up num2, which is 4.8. Again, if I look at the code, I mistakenly do 2.4. I'm not going to redo all this work or anything. I'm just going to do what the computer does. Num2, well, that's 4.8. Very little thinking I have to do if I'm doing the same thing the computer does. The computer don't think at all, and it can do this. I'm going to think as little as I can when I'm doing my traces. And that'll be a theme. I'll bring that up a lot. But I like to turn my brain off a little bit doing a trace. It should be mostly automatic. You got to learn the rules of how things work in the trace. Once you learn those rules, you execute them just like the machine does, because that's what you're simulating, is how a computer runs this program. And a computer just follows a set of rules. So y, this is another method call. So it's new stack frame with y, named y. Y has one parameter val, and its argument is 2 as an int literal. And then y is going to print I return nothing to the screen. I return nothing. And there are two ways to end a method call and to end a stack frame. One is by explicitly returning something by using the return keyword, and the other is by hitting the closing brace of that program. For anything with a non-void, any method with a non-void return type, you can't just let the method end by hitting the close brace. You have to have a return statement to specify the value that's being returned. For our void methods, both y and the main method, we don't have the keyword return. We just let them hit the closing brace, and that's what ends the method. So we hit the closing brace of y, cross it out. So the variable val is no longer in memory. It is erased from memory. And then we return execution back to the main method. This resolved to nothing. It just returned void. That's the end of the statement. Move on to the next line. Hit the closing brace of the main method. Cross out the main method. And that's our final trace for this code. That's our final trace is nothing left on the stack, but we still have our stack frames just crossed out, so we can still look through the history of what happened. We had a main stack frame, we had a multiply by 2 stack frame, we had a y stack frame. Here's all our variables, what their initial values were, their final values, any updates in between, and also everything that was printed to the screen throughout the execution of this program. So one thing we could at least do, I can print I am num3 1, I am num2, new num2 4.8, I return nothing. We should at least get all of that if we run this program. So if we go, which we can do, we have IntelliJ open, we have this program ready. Let's run it. Make sure we get all that same stuff. We get all the exact same print statements when we do run the program. So it's one way we can verify, at least to an extent, what we get when we run this program. And since I can't resist, I'll do my first debugger. I'll keep this extremely brief. We don't really have time for this. But if we click a line number, if we click the first line of main specifically here, and then instead of running the program, we'll click the debug button, we can run this program in the debugger. What this does is shows you all of the same information that we put in the memory diagrams, except without our simplifying assumptions. So args is going to be on the stack here, but I have my main stack frame. And as I go through my code, I can click this step into to advance one line at a time, and I can see my main stack frame getting all these variables just like we did in our trace. We can go to console to see what's printed to the screen. We got these two things printed to the screen so far. And then when we have our method call here, multiply by 2, we're in the multiply by 2 stack frame with input having the value 2.4 and then x having the value 4.8. And I can click back to my main stack frame to see what all the variables are here and see all the same variables here as well. Click through here. That stack frame is actually gone because that is what actually happens, but in our traces we would cross them out. And then num2 has been updated to 4.8. When this prints to the screen, I'll jump to the console. Prints to the screen, new num 4.8, new num2 4.8, and then y. In the y stack frame, we have val equals 2. It'll print to the screen. I return nothing. And then that stack frame disappears. It's gone. And then we hit the end of main, and the program ends. So you can see this, all the same information that we did in the trace, you can see in this tool called the debugger, which I'll find time for a more thorough tutorial later in the semester. But you can do all the same information in the debugger. So if you want infinite practice with traces, get good with the debugger and then use that to practice your traces. And that has the double effect of helping you with your assignments. When you're doing a problem set and you're struggling with that, running the debugger will almost always show you what your bug is, what the issue is in your code. All right. Which brings us, so we will spill over a little bit. That brings us to the end of our first slides. We're going to jump to the next one. We'll get as far as we can here. We might be able to get a whole trace done. I'm hopeful. Yes, replace it because I don't know why I do that, but I just do. Let's get some if statements and loops. Okay, so here's our first program that uses an if statement. This program is going to take a numeric grade and output a student's letter grade, which is an example we will revisit quite a bit later in the course. Actually, now in testing week's been really pushed back. But let's talk about if, else if, and else. And I honestly don't have a whole lot to say about this. This program, even if this is literally your first time ever seeing Java, you can probably still trace through this code pretty well. You start with the main method. You're doing letter of 98. Well, we did just talk about this, but integer division, 98 divided by 10 is going to be 9. 9 is greater than or equal to 9, so we're going to return A and then print A to the screen. 75, we get 7. That's going to give us a C. And then 30, it's going to give us a 3. That's going to hit the else, and we're going to print an F to the screen. So we should see A, C, F printed to the screen. That's what this code does. It's looking at the tens digit and using that to be able to figure out what the letter grade should be. And you know what? I better say this right now because last semester I said it way too late and it wasn't relevant anymore. But in your problem set, there's a sum of digits method. The intended solution for that sum of digits method is to use a combination of integer division and modulo 10. So if you take a number modulo 10, that's the percent sign, that gives you the remainder of a division only. So if you take a number and you take it modulo 10, that's going to give you exactly the ones digit. And then if you have integer division by 10, what that'll do is effectively shift all of the digits to the right by 1 and erase the old ones digit. And now what used to be the tens digit is now the ones digit. And now you can modulo 10 again, get the new ones digit, which was the tens digit, and add that to a running total. If you want to add up all of the digits of an integer, you can repeatedly do that. Do modulo 10 to get the ones digit, then divide by 10 to erase that ones digit, modulo 10 to get the original tens digit, then divide by 10, now modulo 10 to get the original hundreds digit, and just keep repeating that until you're out of numbers to read. That's the intended solution for that. Without the intended solution, that one's pretty tough. But the lecture examples are meant to guide you through that. But the modulo part comes in testing week, which is way too late for that. When we switched that, and things just got shuffled. So I want to give that hint out there right now to be able to do that sum of digits. Because otherwise, it's a pretty tough question if you're trying to solve it from scratch. I've seen a lot of creative ways to solve it, but that's my intended solution for that. Why I think it's a fair question, because we walk through the examples in lecture. Okay, so conditionals in Java, indentation doesn't matter. The code blocks are defined by the braces, open brace and close brace for each code block. And if you're coming from Python, Python's kind of the oddball out. It says elif instead of spelling out else if. It's one of the weird things with Python, where Python will spell out everything to be basically English sentences. Then for else if, they just randomly delete 3 characters. I don't know why. But else space if is how else if is written in Java, and then else. And the behavior is just like you would expect. It doesn't matter what language you're coming from, Python or whatever else. The syntax for a conditional is the same in just about any language, certainly any language you would take for a CS1 course. It's if and then some Boolean expression, else if some Boolean expression, and then if all the expressions are false, we'll go to the else and fall through. Okay, and let's see that in a memory diagram. We'll at least get through this trace. I'm pretty confident. So let's go to our code. Lecture example. Oh, yeah, plus minus. Actually, this is kind of a big example. So let's spin all this. Don't ask, I'm sure. I'll never make a mistake. Okay, let's trace through this. So every Java program starts with a main method, and I'll start going through these a little quicker. The first one, just in case you've never seen a trace before, I wanted to explain quite a bit. But here I'll start picking up the pace. So letter, until we get to the new concept, of course. So letter, this is a new stack frame called letter. It's going to return to a variable named result. And we do put the variable on the stack with no value, just so we have a place for the return arrow to go to. And then letter takes a parameter of named score, which is getting a value 98. And then we're going to create a variable tens. It's going to be integer division score divided by 10. So this is going to get the value 9. And then if 10's greater than or equal to 9, return A. So this method ends, and we get the value A returned in result. That's a whole method call. We have another method call. Oops, I didn't print it to the screen. Print A to the screen. And we have another call to letter. And we will have stack frames. If we call the same method multiple times, we get 2 stack frames with the very same name. That's fine. That's just, that's the way we roll. When we're grading, we'll know. We'll look at all the context clues, the parameter values, and everything, and figure out if you trace through everything properly. So we have 75, and then tens is going to be 7, because we have integer division. And then we have if 10's greater than or equal to 9, that is false. So 7 greater than or equal to 9 is false. So we go to the else if. 7 greater than or equal to 8 is false. So we go to the else if. 7 greater than or equal to 7 is true. So we're executing this block. And this is a new thing for Java that we haven't seen in Python. The way Python handles code blocks is different. With Java, we're going to use this create code block button, which has always existed, but in 1.15 you just would never touch this button. But create code block. Whenever we have a code block inside of a method, we're going to create a code block and put all of our variables that are declared inside of that code block inside of this dashed box for that code block. The reason for this is when a code block ends in Java, any variables that were declared inside of that code block are destroyed as soon as that code block ends. So we do have to be careful about how we create our code blocks, which admittedly isn't very important for this one because we're ending the method call inside of this code block, but it will be important for, moving forward. We will have to keep track of this. So this is your first taste of it. I'll wait for the next one. So we have this code block, and then the method ends, we're returning C. So the code block ends, so return is no longer in memory, but the entire method call ends as well. We return C, I forgot my return arrow. We return C back into the main method, and then print C. And we have one more call of letter, where score is 30. Tens is going to be 3. And then we're going to go through 3 greater than or equal to 9, false, 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 and we hit the else, and else return F. So we do have a code block here. We enter a code block, but you notice for the first call of letter, I didn't create the code block. I didn't bother with that. And I'm not going to here either. So I can create the code block, but there won't be any variables declared in it. The reason to trace through our code blocks is to keep track of which variables are currently in memory. So once that code block ends, any variables declared in it are removed. That's the only purpose of tracing code blocks. So if you have a code block and there are no variables declared in it, we don't have to trace that code block. Another thing that we're just not going to force you to go through the tedium. There is a code block here, so if you do want to trace these and have your code block and just put no variables in it by deleting the variable that's created by default, that's fine. That's good. You can do that. You're more than welcome to do that on your traces, but you're also more than welcome to just omit the code block entirely if you have a code block with no variables declared within it. You can just omit the entire thing completely, and that's perfectly fine. And then this will return F. I got to get my return arrow. Frame ends, and then we have the value F in result, and then print result to the screen, print F. And for what it's worth, this is a very minor thing, but if you really want to be particular about things, when I have a variable of type string, I'm going to put the value in double quotes. And when a string is printed to the screen, I'm not printing it with the double quotes. Because that's the way the program does behave. If I won't go back to the debugger right now, but the debugger, when it shows your strings, it will show them in double quotes. But when you print to the screen, you don't get double quotes all over the place. It'd just be a lot of clutter in the output. So there's no double quotes around what's printed to the screen. And hell, we did get through that trace. That one actually goes pretty quick. So let's jump back to our slides. We can at least introduce loops, though we won't get to the loop trace today. Let me jump out of presentation mode. Skip through. So again, I have the memory diagram in the slide still. I left my old memory diagram, so if you want to go through my commentary on here, you're more than welcome. Download from the course website and go through them all. I'm going to skip it in lecture though, because I did it in the tracing tool. So loops, we have a few different flavors of loops. We have our while loop and our for loop in Java. And a while loop is, which actually I think they teach you in 115, but if you haven't seen while loops before, let's just go over them briefly. A while loop has the same syntax as if statements. So we're going to say, while some Boolean expression, execute this loop. And as long as this Boolean expression is true, we're going to keep going around the loop. So we're going to check this expression. If it's true, we execute the body of the loop. Then we check the conditional again. If it's true, we execute the body of the loop again. Then we check the condition again, and we just keep doing this until the condition is false. Then we skip to the end of the loop and continue with the program. So we're going to loop while the condition is true or until the condition is false. Notice that a while loop, and actually a for loop as well in Java, or any program, I suppose, any language, doesn't have to execute at all. So this while loop, the way we have this set up, this while loop will not even execute a single time. So don't use the body of your loops to initialize anything, because you might get your values uninitialized. If this is the situation, then val -5 greater than 1 is false, and then this loop never, ever, ever executes. So if you're doing like a min problem, you want to find the min of some value, and you're like, well, the first iteration of the loop is just going to get the value of the first whatever in my data structure, and go from there. That's not always going to happen. If the data structure is empty, for example, you're just going to return your default value. So just something we always got to keep in mind when programming. Your loop might not execute any times. It might execute 0 times. And then the for loop, you can get the definition. I'll probably revisit this next time, just to, actually, maybe I'll go right to the memory diagram, but let's at least get it out there. The for loop in Java is composed of 3 statements. In Python, you wouldn't even have this style of loop. For some reason, Python decided to not give us this style of loop. For Python, this would be for x in range of 5. Would be the same thing here. This is the style of loop in most languages, most mainstream languages at the very least, where we have 3 statements. We have an initialization statement, which is executed 1 time when we first reach the loop. A conditional, which behaves the same way as the condition for a while loop. We're going to execute while this condition is true. And then an increment statement, which is executed after each execution of the body of the loop. And we're going to use some, I'll reiterate that, but we're also going to use some extra syntax, some fancier syntax than we do in 115. 115, we don't even have this syntax available, this plus plus syntax, this increment operator in Python. But even if we did, we like to avoid it in 115. It just causes too many issues. But for people brand new to programming, it can people do like x plus plus equals x plus 1 and end up incrementing twice. They just get things confused like that. In 116, you're ready for more advanced syntax. So x plus plus is the same as saying x equals x plus 1. So what this will do is increment x by 1. It does seem simple when I say it like that, but when you combine that with assignment operators, there's a hidden assignment operator can confuse students. But you're all good for that right now. And this is the structure of it. So we're gonna get to the loop, execute the initialization, check the expression. If the expression is true, execute the body of the loop, then execute the increment statement, and then check the condition again. If the condition is still true, keep looping. And we'll do the memory diagrams for conditionals and loops. No, we already did conditionals. For loops when we start on Thursday, but my alarm went off. It's my cue to not hold you hostage to get out of here. So I'll jump right to office hours. If you go to the Piazza post for the office hour schedule, here's the link for the Zoom meeting. I'll join that meeting. Make sure I have it written right here, but if we use breakout rooms for office hours, so I'll be in a breakout room. So if you do join office hours, it might look like you're in the room by yourself, but I'll see you, call you into the breakout room, and then answer your questions there. I might be with another student, so if somebody showed up before you, I pulled them into the breakout room, I might be helping them, and then once I'm done with them, I'll call you in. So it might just look like you're sitting in a meeting by yourself, and you're looking around wondering what the hell is going on. I'm probably with another student in the breakout room, so just chill for a sec, and I will get to you. If it's during office hour time, I'll be there. I can't miss office hours because it's right after lectures, so it's not like I can forget about it. I'll be there. I will be there, but I will be in a breakout room. If I'm not with anyone else, you'll join the meeting, and I'll call you into the breakout room right away. But I'll head over there. If anybody has questions, hit me up in the Zoom office hours. Other than that, I'll see y'all on Thursday for more Intro to Java. Take care, everyone.